Good morning to all. Can I audible?
Yes, sir.
Okay.
Yes, sir.
In the previous lecture, we seen that the derivation for elimination the constant. Okay. What is the definition of partial differential equation and the derivation of the partial differential equation by eliminating of arbitrary constant. Okay. So today we will discuss what is the curvature. Sorry, what is the curve and surfaces? What is the equation of curves and surfaces in 3D space? Okay. Let's see. Before going to the second method to solve the PDE, we will discuss what is the equation of curves and surfaces. Okay, now look at here. Equation, sorry, curves in curves and surfaces. Okay, look at it. What is the curves and surfaces in 3D space? Okay, tell me what is the equation of curve in two-dimension space? एखाद्या कर्वचं इक्वेशन काय असतं टू डायमेन्शन मध्ये सपोज in two dimension space there is a line. Okay, so what is the equation of line in 2D space? Line ही एक कर्व असते ना 2D मध्ये. So what is the equation of line in two dimension space? Anyone know? Okay, so the general equation the general equation of line, okay, in plane, that means in two dimension, it's given by what is the equation of line in two dimension space? माहित आहे का? ax plus by plus c is equal to 0. Okay, y is equal to mx plus c. पाहिलंय ना काय equation
Yes,
of
sir.
line? हा, so this is the equation of line two dimension space. Okay, now tell me what is the equation of line in three dimension space? 3D space मध्ये इक्वेशन ऑफ लाईन कसं दिले, कसं असेल? डिफरन्शियल जॉमेट्री शिकलायत ना? डिफरन्शियल जॉमेट्री शिकलाय ना डीजी?
Yes, sir.
मग काय असणार एखाद्या कर्व किंवा एखाद्या स्ट्रेट लाईन असू स्ट्रेट लाईन हे सुद्धा एक कर्वच आहे थ्री डायमेन्शन स्पेस मध्ये. सो व्हॉट इज द इक्वेशन ऑफ स्ट्रेट लाईन, ओके, एनी लाईन और कर्व इन थ्री डायमेन्शन स्पेस काय असेल? ओके, माहित नसेल तुम्हाला, लक्ष द्या इकडे. अ कर्व, look at the definition. A curve may be specified by means of parametric equation, by means of parametric equation. ओके, एखाद्या कर्वचं इक्वेशन 3D स्पेस मध्ये कसं दिलं जातं? पॅरामेट्रिक इक्वेशन नुसार दिलं जातं. ओके, सपोज f1, f2 and f3, okay, are continuous functions, are continuous functions functions of a continuous variable t, continuous variable t. Okay, so this is the variable t which which varies in an interval. Okay, in an interval I, which is the subset of R. Okay, then the then the three equations of a curve of a curve in 3D space in 3D space. Okay, look at here. If I belongs to R, then the three equation, sorry, then the three equation, then the three equation x is equal to f1 of t. Okay, y is equal to f2 of t, and z is equal to f3 of t. Okay, represents the parametric equation of curve. Okay, parametric equations of curve. Okay, now look at it. Example. The simplest form. The simplest example of a curve of a curve in space is a straight line. Okay, straight लाईनचं इक्वेशन काय असणार 3D space मध्ये straight line with direction cosines. Okay, direction cosines L, M, and N. Okay, passing through passing through a point x naught, y naught, and z naught. Okay, with parametric equation. Parametric equation. What are the parametric equation of straight line? काय असणार? डीजी मध्ये शिकले आपण. x is equal to x naught plus L into S, where this S is the variable. Okay, y is equal to y naught plus M into S, and Z is equal to what? Z naught plus N into S, where this S is belongs to parameter, which is belongs to R. Okay, so these are the equation of straight line in 3D space. Okay, 2D space मध्ये equation of line काय असणार? अशा असणार. Y is equal to mx plus c. This is the equation of straight line, one form of equation. Okay, straight line. So in general, the equation of line in 2D space ax plus by plus c is equal to 0. मग तुम्ही म्हणचाल 3D मध्ये ax plus by plus cz plus d is equal to 0. जर असं घेतलं तर तो इक्वेशन ऑफ प्लेन इन 3D स्पेस होईल. ओके, तुम्ही म्हणसाल जर ax plus by plus c is equal to 0. So this is the equation of line in 2D. Okay, मग 3D मध्ये असं घेताल तुम्ही ax plus by plus cz plus d is equal to 0. This is the equation of straight line. Is it the equation of straight line in 3D? No. So this is
Mm.
the equation of plane. शिकलाय ना BSc first year.
Yes, sir.
Okay, so this is the equation of plane in 3D. So any equation in 3D plane, 3D space, the equation of curve or any straight line is given by parametric equation. And this is the equation of straight line, okay, with parameter yes. Okay, आता हे इक्वेशन कसं आलं बघूयात आपण. हे इक्वेशन कशी येतात स्ट्रेट लाईनची. सपोज जॉमेट्री येते, डिफरन्शियल जॉमेट्रीमध्ये तुम्ही शिकला असाल. इफ सपोज This is
Hello, sir.
x-axis, and this is
Sir.
ah, kind out.
So some students wants to join the class.
Okay, wait for a minute. Okay. Okay, suppose this is x-axis, this is y-axis, and this one is the z-axis. Okay, suppose this is z-axis. Okay, if suppose you have to find the equation of line, this one. Okay, suppose this is the line, so you have to find the equation of this line. ओके. जर तुम्हाला या इक्वेशन ऑफ लाईन या लाईनचं जर इक्वेशन काढायचं असेल विथ पॅरामीटर टी, so you know must be point P naught, okay, which is x naught, y naught, and z naught. Okay, so this is the coordinates of P naught, where P naught is the point on the line. Okay, and this is in general any point on the line P, X, Y, Z. Okay, so join this one and this one. So this is, suppose this is R naught and this is R. Okay. To find the equation of line, you must know one point on the line and the direction of that line. Using that equation, using the point x naught, y naught, z naught on the line and the direction vector v bar a, b, c, our aim to find the equation of line in L, okay, which goes through the point p naught and parallel to p naught. ओके. जर या इक्वेशनचं तुम्हाला या लाईनचं जर इक्वेशन काढायचं असेल तर तुम्हाला याचं डायरेक्शन माहिती पाहिजे. ओके, सपोज दिस लाईन एल, दिस इज द लाईन एल, and you have to find the equation of that line L, you must know the direction of this line. Okay, so take one more line which is parallel to this line. Okay, suppose this is the V bar and the general coordinates of this line is point is A, B, C. Okay, so this is R bar, this one is, and this is R naught bar. Okay, so using vector addition, give it point O, here the O, here is, this is the P, and this is the P naught. Okay, so what we have then by vector addition, we know that O P naught bar plus P naught P bar, this vector plus this vector, addition of these two one, okay, is equal to what we have then O P bar. Okay, so we have to find the equation of P naught and P. So here we get P naught P bar is equal to OP bar minus OP naught bar. Okay, so this is OP means what? R bar. OP naught bar means R naught bar. Okay, so this is P naught and P bar, which implies, but what is P naught P? P naught P. Okay, so this line L is parallel to this line V bar. Okay, so we have this line Akasnar multiple of this one. Okay, line L P naught P Akasnar is equal to T into some V bar. Why? Because this line V bar is parallel to line L. जर दोन लाईन्स पॅरलल असतात तर त्याच्यामध्ये काय डिफरन्स असतो, तो एकमेकांच्या मल्टिपलमध्ये असतो. ओके, सो दिस इज पी नॉट पी इज नथिंग बट टी इंटू व्ही बार इज इक्वल टू आर बार मायनस आर नॉट बार, विच इम्प्लाइज दॅट आर बार is equal to R naught plus T into V bar. So in the coordinate form, what is the coordinate of R bar? Here, X, Y, Z. Okay, so what is the coordinates of R naught bar? This one, P naught. In the coordinate form, we can write like this. Z naught. Okay, plus T into what is the V bar? A, B, C. So What we get? X is equal to x naught plus dA. Y is equal to y naught plus what? dB. And Z is equal to Z naught plus dc. Okay, so this is the equation of line, straight line in 3D space, with t running from p naught to p. Okay, t running from I. Okay, so this is the equation of line in parametric form. Okay, now wait a minute. If t is equal to 0, put t is equal to 0. जर p जर मी 0 ठेवला t जर, तर काय येणार? x नॉट इज इक्वल टू x. हा जो x नॉट पॉईंट कुठे येणार? x कडे येणार. हा तुमचा पॉईंट कुठे कुठे सरकत जाणार? x कडे जाणार. ओके, समजा तुमचा t जर पॉझिटिव्ह असेल, t जर पॉझिटिव्ह असेल, ग्रेटर दॅन 0 असेल, तर काय येणार? तुमचा p नॉट हा कोणाकडे जाणार? हळूहळू p कडे जाईल. ओके, त्याच्या जवळ जाईल. आणि जर तुमचा टी जर निगेटिव्ह असेल, तर तुमचा हा पी कुठे जाईल? पी नॉटच्या हवे जाईल, या दिशेला जाईल. ओके, तर पी जर टी जर पॉझिटिव्ह असेल तर या साईडला जाईल तो पॉईंट. ओके, टी जर 0 असेल तर कोणाकडे येईल? पी नॉट इज इक्वल टू पी होईल. आणि टी तुमचा जर पॉझिटिव्ह असेल, तर हा पॉईंट निगेटिव्ह असेल तर कुठे जाणार? अगेन द हवे जाणार, पी नॉटच्या या डिरेक्शनला जाईल, अपोजिट डिरेक्शन. Okay, so this is the equation of line in 3D space in the parametric form. Okay, any doubt? Any doubt आहेत का याच्यात?
No, sir.
No, sir.
Now the second point. Similarly, a right circular helix. हे डीजी मध्ये शिकलाय तुम्ही. Circular helix in is a space. Okay, curve line on a circular cylinder. On a circular cylinder. And is given by the following parametric equation. Following parametric equation. What is the parametric equation of helix? X is equal to काय येणार सांगा? पाहिलं ना डीजी मध्ये? A cos wt omega t. Y is equal to A sin omega t. And what is Z? काय येणार?
B.
काय? सांगा, चुकलं तर
B,
चुकलं.
sir.
bt or kt. Okay, where t belongs to r, real number. Okay, and where a, omega and k are constant. Okay, so this is the equation of helix, right circular helix in 3D plane. Sorry, 3D space. Okay, now what is the equation of surface in 3D space? हे झाले कर्व्स. आता equation of surface काय असणार? Look at here. Number second, surfaces. Okay, if x y z be the any point, x y z be any point in space, then the surface is a functional relation. Is a functional relation. Okay, functional relation in variables x, y, z, and is given by f of x, y, z is equal to 0, where f is a continuously differentiable function. Okay, continuously differentiable function defined on domain. Defined on a domain. Okay, now tell me what is the equation of surface in what is the equation of sphere in 3D space? Sphere equation क्या है ना?
X square plus y square plus z square is equal to a square. If radius is a.
Square plus y square plus z square is equal to a square if radius is a. And what is the origin of this one?
Origin is 0.
Origin is 0. Okay. So if suppose this is the equation of sphere in 3D space. Okay. So what it implies then? F of, sorry, x square plus y square plus z square minus a square is equal to 0, where f of x, y, z is equal to 0, and f of x, y, z is what? Is equal to x square plus y square plus z square minus a square. Okay, now tell me what is the equation, parametric equation of sphere. झालंय तुम्हाला हे? What is the parametric equation of sphere in 3D space? हे झाले coordinate form मध्ये झालं. Okay, so parametric equation. Parametric equation of sphere in 3D space. Okay, suppose if x is equal to f1 of uv, y is equal to f2 of uv functions in u and v, and z is equal to functions of f3 of uv. Okay, give it as an equation number 1. कोणतेही 3 x y z असे पॉइंट घ्यायचे की हे इक्वेशन सॅटिस्फाय करायला पाहिजे तुमचे. ओके, हा इक्वेशन जर सॅटिस्फाय केला, if x is the function of uv, y is the function of uv. Okay, so parametric equation of the sphere in 3D space is what? X is equal to पाहिलंय आपण a sin v cos u. Okay, y is equal to what? A sin u cos, sorry, sin v, and what is z? A cos v. Okay, so this is the first characteristic equation, sorry, parametric equation for this sphere. Now put x, y, z in this one. हे तुम्हाला 0 मिळाले. Okay, so any x, y, z which satisfies this equation, then it is the parametric equation of the sphere in 3D space. Okay, now the another one, the parametric equation of sphere, the second parametric equation of the sphere in 3D space is what? If suppose x is equal to a 1 minus v square upon 1 plus v square into cos u, y is equal to a into 1 minus v square upon 1 plus v square into sin u, and z is equal to 2ab upon 1 plus v square. So these are the also parametric equations of sphere. Okay, so hence the parametric equation of any surface in 3D space is not unique. Okay, The parametric equation of any surface in 3D space is not unique. ओके, एकाच तुमच्या सरफेसला दोन दोन पॅरामेट्रिक इक्वेशन्स मिळू शकतात. ओके, एनी डाऊट?
No, sir.
नाव आता जाऊयात आपल्या कालच्या एक्झाम्पल. ओके, look at here. Some remarks are there. Okay, what are the remarks? First one, if number of number of arbitrary constant, arbitrary constant, okay, less than number of independent variables, number of independent variables, then the elimination of arbitrary constant, elimination of arbitrary constant elimination of arbitrary constant usually gives rise to more than one partial differential equation, okay, of order 1. Okay, for example, look at here. If z is equal to ax plus y, so what is the arbitrary constant here? A is the arbitrary constant, which is only 1. And what are the independent variables?
X and Y.
X and y. So here the number of arbitrary constant is less than number of independent variables. Then the elimination of the arbitrary constant usually gives rise to more than one partial differential equation of order 1. Now, give it as an equation number 1. Now, partially, differentiate 1 partially with respect to x and y. X and y. So here we get dou z by dou x, which is equal to p, which is equal to a. Okay, and dou z by dou y, which is equal to q, which is equal to what?
1.
And
X. One,
x.
one, one, one.
1.
Okay, so here we get p is equal to a and q is equal to 1. Okay, hence we get z is equal to, what is the value of a is p, so px plus y. Okay, so this is one partial differential equation and q is equal to 1. So here we get more than one partial differential equation of order 1 if number of independent variable is more than number of arbitrary constant, or number of arbitrary constant is less than number of independent variables. Okay, understood?
Yes,
Yes,
sir.
sir.
Okay. Now the second remark is the number of arbitrary constant. Number of arbitrary constant. Okay, if number of arbitrary constant is equal to number of independent variables. Okay, number of independent variable. Then the elimination of arbitrary constant shall give rise to unique partial differential equation. Unique partial differential equation of order 1. Okay. Now the third one. ह्याचे एक्झाम्पल आधी बघितलेले आपण. ओके, काल बघितलेले. नंबर ऑफ आर्बिट्ररी कॉन्स्टंट ए आणि बी असताना इंडिपेंडेंट व्हेरिएबल एक्स अँड वाय होते, तेव्हा युनिक तुम्हाला पार्शियल डिफरन्शियल इक्वेशन मिळतं ऑफ ऑर्डर 1. Look at here. Now look at here. Number of arbitrary constant here a and b, and number of independent variable x and y. So it gives the unique PD xq xp plus qy is equal to q square. So this is the unique partial differential equation of order 1. Okay, this q square आहे, not order 2 नाही येते. Okay, प्रत्येकाची ऑर्डर 1च आहे इकडे. फर्स्ट ऑर्डर पार्शियल डिफरन्शियल इक्वेशन. Okay, any doubt? Now the third one, number of arbitrary constant. Number of arbitrary constant is greater than the number of independent variables. Then the elimination of arbitrary constant leads to partial differential equation, usually of order greater than 1. For example, z is equal to ax plus by plus cxy. Okay, so here the number of arbitrary constant are a, b, c, which is 3, and number of independent variables are x and y. Okay, now differentiate partially with respect to x and y. Okay, differentiate partially with respect to x and y. We get what we get? Dou z by dou x, which is equal to p. Okay, which is equal to a plus cy. Okay, so this is equation number 1. Now differentiate with respect to y. So we get dou z by dou y, which is equal to q is equal to b plus cx. Give it as equation number 2. Now again differentiate partially with respect to x. इथे आर्बिट्ररी कॉन्स्टंट आहेत तुमच्या अजून a and c. इथे काय b and c. आपल्याला हे दोन्ही काय करायचे आहेत? एलिमिनेट करायचे आहेत. Again differentiate partially with respect to x and y. So here we get here dou z by dou x. Now we get dou 2z by dou x square, which is equal to 0. Dou 2z by dou y square is equal to 0, and dou 2z. Now differentiate this with respect to y. Okay, here we get dou x into dou y, which is equal to c. Okay, so these are the partial differential equation of order greater than 1. Now multiply x by 1 and 2 by multiply x to 1 and y to equation number second. So we get what we get, x into dou z by dou x, okay, which is equal to ax plus cxy, and y into dou z by dou y, which is equal to by plus cxy. Okay, या इक्वेशनला मल्टिप्लाय केला आपण, याला x नी आणि याला y नी. Okay, now adding equation 3 and 4. So this is equation number 3 and this is equation number 4. So adding 3 and 4, we get 3 and 4. We get x dou z by dou x plus y dou z by dou y, which is equal to ax plus by plus cxy plus cxy. Okay, but this is with what? Ax plus by plus cz, which is equal to z. And what is cxy? Here, what is cxy? xy into the xy ने multiply करा काय येणार, x into y. So here cxy. What is the value of cxy? This one. Plus dou 2z by dou x into dou y into xy. Okay, so this is x into dou z by dou x plus y into dou z by dou y, which is equal to z plus dou 2z by dou x dou y into xy. So this is the partial differential equation of order greater than 1. Okay, if number of arbitrary constants are greater than number of independent variables. Okay, any doubt up to here?
No, sir.
Okay. Now the second method, today second derivation of partial differential equation by eliminating the arbitrary function. Okay, now look at here. Second, काल बघितलं आपण first part by eliminating the arbitrary constant. Now the derivation of partial differential equation by elimination of arbitrary function. Okay, result. Find the partial differential equation. Find the partial differential equation satisfied by all the surfaces okay of the form f of uv is equal to 0, where u is equal to u of xyz. Okay, u is the function of xyz and v is the function of xyz, which is equal to v. Okay, and f is arbitrary function of u and v. Okay, u and v. Okay, find the partial differential equation satisfied by the all the surfaces of the form f of uv is equal to 0, where u is the function of xyz and v is the function of xyz and f is the arbitrary function of u and v. So okay, so in general we are going to prove. Okay, नंतर examples घेताना तुम्हाला particular example येतील. Okay, now look at the proof. Okay, consider the equation. Is the equation f of u and v is equal to 0. Give it as an equation number 1, where u is equal to function of x, y, z, and v is the function of v of x, y, z. Okay, now differentiate one partially with respect to x and y. We get what we get now. नीट लक्ष द्यायचं काय म्हणा. Okay, first differentiate partially with respect to x and y. Okay, equation number one. F is the function of u and u is the function of x, y, z. And also z is the function of x, y. So here the z is dependent on x, y. Okay, need लक्ष द्या. So here we are going to use the chain rule. Okay, now first one, dou f by dou x. Dou u. Why? Because f is the function of u and multiply by u is the function of x. Okay, plus u is the function of z and z is the function of x. Okay, कळते का कसं लिहितोय? Again, plus f is the function of first v into f is the function of v and v is the function of then x plus so v by v is the function of first z, then z is the function of x. Okay, so this is the partial derivative of 1 with respect to x. Partial derivative. Okay, any doubt up to here? काय कळत नाही याच्यात? नीट लक्ष द्या काय. आधी f is the function of u आहे, u is the function of x, y, z. त्या x, y, z मध्ये पण डिपेंडेंट कोण आहे? z डिपेंडेंट आहे. कोणावर? x आणि y वर. Okay, hence we get first f is the function of u into and u is the function of x plus okay y with respect to y काय येणार 0 येणार, त्यामध्ये लिहायची गरज नाही. Plus u is the function of then z is the function of x. We are going to use here the chain rule. Similarly for the v. Okay, any doubt?
No, sir.
Now differentiate partially with respect to y now. Okay, and dou f by dou v. Okay, first f is the function of u, first one. Now I am going to differentiate with respect to y. Okay, f is the function of u, u is the function of y plus with respect to x काय येणार 0 येणार, त्यामुळे प्लस 0 लिहायची गरज नाहीये. Again, u is the function of z, then z is the function of y. Okay, plus then again f is the function of v into now v is the function of y plus v is the function of x लिहायची गरज नाही आहे इथे, with respect to y करतोय आपण. Okay, here then we use v is the function of z into now z is the function of y. Okay, which is equal to 0. Give it as an equation number 3. Any doubt up to here? Any doubt up to here?
No, sir.
Now the equation 2 implies that, look at here, dou f by dou u, we can write f into u. Okay, into bracket u with respect to x, ux. Okay, plus u with respect to z, uz into dou z by dou x means what? P.
P.
Plus similarly f v into bracket vx plus vz into p, which is equal to 0. Okay, give it as an equation number 4. And equation 3 implies fu into uy plus uz into q plus fv into vy plus vz into q. Okay, any doubt?
No, No,
Any doubt
sir.
up to
No,
here?
sir.
No, sir.
No. From equation 4 and 5, we get, look at it, from equation 4 and 5, we get, look at it, fu upon fv is equal to, from equation 4, what we get here? Minus vx plus vz into p upon ux plus uz upon into p. Okay, and fu, equation 5 implies fu upon fv, which is equal to minus sign vy plus vz into q upon uy plus uz into q. Okay, so this is equation number 6 and this is the equation number 7. From equation 6 and 7, what we have? Both are equal. Okay, from equation 6 and 7, we get, what we get? Vx plus Vz into P upon Ux plus Uz into P, which is equal to Vy plus Vz into Q upon Uy plus Uz into Q. Okay, so both are equal. Now simplify this one. If we simplify, we get Vx plus Vz into P into Uy plus Uz into Q, which is equal to Vy plus Vz into Q into Ux plus Uz into Q. Sorry, P. Okay. Now multiply. We get, simplify that this one. Vx Uy plus Vx uz into q plus Vz uy into p plus Vz uz into pq, which is equal to Vy ux plus Vy uz into p plus Vz x q plus vz uz into pq. Okay, any doubt up to here?
No, sir.
No, cancel this one, uz vz pq, and this is uz vz pq. Okay, so after simplification we get here vz uy minus vy uz into p in the first bracket, and the second bracket vx uz minus vz ux into q, which is equal to vy ux minus vx uy. Okay, after simplification we get this one. एल करता है, काय डाऊट आहे?
No, sir.
ओके, ह्याच्यातनं पी कॉमन काढलाय आपण, ह्याच्यातून आणि ह्याच्यातून. ओके, क्यू कशातून कॉमन काढलाय? ह्याच्यातून आणि याच्यातून. ओके, मायनस तिकडे गेल्यानंतर मायनस होणार, आणि हा एका ब्रॅकेटमध्ये घेतला. ओके, विच इम्प्लाइज that this is the Jacobian of uv with respect to yz. Okay, into small p plus this is the Jacobian of uv with respect to xz or zx. Okay, zx. Okay, this is z and this is x into small q, which is equal to, this is the Jacobian of uv with respect to xy. Okay, that is capital P into small p plus capital Q into small q, which is equal to R. Okay, where capital P, capital Q, and capital R are the functions of the functions of x, y, z, and this is the required partial differential equation satisfied by all the surfaces all the surfaces of the form f of uv is equal to 0, and it is also called as काय म्हणायचं इथला बीएससी ला शिकलाय इट इज ऑल्सो
Bernoulli's
कॉल्ड
equation.
काय
Bernoulli's equation.
नक्की इट
Not
इज
sure.
ऑल्सो कॉल्ड as
Lagrange's equation.
Lagrange's partial differential equation. ओके, या इक्वेशनच्या फॉर्मला काय म्हणतो आपण डायरेक्ट आपण हे बीएससी मध्ये आपल्याला हे देत होते माहिती आहे का
Yes, sir.
सरळ सोल्युशन काढत होतो ओके इक्वेशन ऑफ सर्फेसेस काढत होतो कंप्लीट सोल्युशन ओके सो दिस इज द Lagrange's partial differential equation. Okay, any doubt up to here?
No, sir.
Okay, now take one example. आता तुम्हाला व्यवस्थित कळेल. Example number 1. Eliminate the arbitrary function. Eliminate the arbitrary function. Arbitrary function and find the corresponding partial differential equation. Okay, now the first one. Z is equal to x into y plus f of bracket x square plus y square. Okay, now using partial differential, we have to remove the function f of uv, f of x1. Okay, now here given to us z is equal to x into y plus f of x square plus y square. Give it as an equation number 1. Now differentiate partially differentiate 1 partially with respect to x and y. So we get what we get dou z by dou x means p is equal to y plus f dash of x square plus y square into 2x,
2x.
which implies that f dash of x square plus y square is equal to p minus y upon 2x. Any doubt? Calculation part is okay. Any doubt?
No, sir.
And q is equal to x plus f dash of x square plus y square into
2y.
2y आहे ना लक्ष, which implies f dash of x square plus y square is equal to q minus x upon 2y. Okay, give it as equation number 2, and this is the equation number 3. So from 2 and 3, from 2 and 3, we get p minus y upon 2x, which is equal to q minus x upon 2y. Remove these two to get cancelled. So what we get here? Y into p minus y, which is equal to x into q minus x. So which implies that which implies yp minus x cube plus x square minus y square, okay, is equal to 0. So this is the required partial differential equation. So this is the required partial differential equation. Okay, any doubt up to here?
No, sir.
Okay, now the second example. F of x minus z and y minus z. Okay, f of x minus z and y minus z is equal to 0. Okay, now answer. The given function is of the form, is of the form f of u and v is equal to 0, where what is u? X minus z, and what is v? Y minus z. Okay, now calculate the capital P. Okay, capital P of xyz. P is the function of xyz na. So what is the P of P म्हणजे काय तिथे? Tau of uv with respect to yz.
Wise.
ओके, काढता येईल हे? काय ना हे? uy uz py vz. कॅल्क्युलेट करा हे. किती येतं सांगा मला. u with respect to y काय येणार? मायनस क्यू. ओके, u with respect to z minus 1. Okay, v with respect to y, which is 1 minus q. Okay, v with respect to z minus 1. काय ना याची व्हॅल्यू सॉल्व करा, हे डिटर्मिनंट 1 येईल. ओके, सिमिलरली q of x y z is equal to Jacobian of uv with respect to Jacobian of zx. ओके, काढता येईल. त्याचप्रमाणे हे कॅल्क्युलेट करा. नाव व्हॉट इज द आर ऑफ एक्स वाय झेड? Jacobian of uv with respect to
XY.
एक्स वाय, हे फाइंड करा. ओके, यू आणि व्ही आहे तुमच्याकडे. ओके, हे दोन्ही फाइंड करा. जे काय व्हॅल्यू येतील ते कशात ठेवणार? द रिक्वायर्ड पार्शियल डिफरन्शियल इक्वेशन. द required partial differential equation is what is capital P into small p plus capital Q into small q is equal to R. Okay, ह्याच्यात ठेवा, and which is the required partial differential equation of order 1. Okay, any doubt?
No,
Doubt
sir.
आहे? हे सॉल्व करा. Number 3, z is equal to x plus y plus f of xy. Okay, and fourth one is z is equal to f of x upon y. Okay, okay, any doubt in this lecture? लिहून घेतलं दोन एक्झाम्पल.
Yes, sir.
So any doubt in this lecture?
No, sir.
समजते शिकवलेलं व्यवस्थित?
Yes, sir.
काही अडचण असेल तर तुम्ही विचारू शकता.
Okay, sir.
Okay, wait a minute, attendance घेऊ. Wait a minute. Okay, so thank you for the attending the lecture. So you can leave now. Okay, thank you.
Thank you, sir.